Hi, Professor Baldwin here, and today we're going to talk about linear and compound inequalities. Solution sets to linear inequalities can contain infinite numbers of elements, right? It could be a whole number line. And the solution set is represented in either set builder notation or an interval notation. Remember, interval notation would be A through B, and you'll have parentheses or brackets. And set builder will be your variables such as x, and then the vertical line saying such that, and then whatever the restrictions are. In example 1, we're going to solve the inequality. We're going to then graph the solution set and write the solution set in set builder notation and interval notation. Okay, first step. We have a fraction. What do we want to do with that fraction? We want to eliminate it. So to eliminate the fraction, you multiply by the LCD, which is 2. So all three of these terms get multiplied by 2. That gives us 16 is greater than or equal to negative 5y minus 4. Good, fractions are gone. Now we need to slowly isolate that variable y. Let's add 4 to both sides. That'll give us 20 is greater than or equal to negative 5y. To isolate y, we're going to divide by negative 5. 20 divided by negative 5 is negative 4. Remember, whenever you divide or multiply by a negative, you have to flip that inequality. So it flips to less than or equal to and y. Well, this looks a little awkward. We're used to seeing our variable first, so we can rewrite that as y is greater than or equal to negative 4. And we can put this on a number line. We have our negative 4 here, and to be greater than or equal to negative 4, we need a bracket at negative 4, and we shade to the right, which is towards positive infinity. This spits out that interval notation, which is negative 4 through infinity, where this simplified inequality gives us our set builder notation. We do the braces, we write our variable, which here is y, such that, and then we write the restriction on y. And that restriction is that inequality. Y has to be greater than or equal to negative 4. And then we close the braces. Okay, what if we have a compound inequality? A compound inequality is simply two inequalities at the same time, and they're joined by the words and, or. We have two steps to solving this compound inequality. Step 1, you solve each individual inequality. So you're getting it down to the variable is greater than, less than, equal to, and the constant. And then we determine what we have based on the and or the or. So let's stick to step 1 right now, and we're going to solve each of these individual inequalities. With our first inequality, we have a 3 that needs to be distributed. That'll give us 3x minus 6 plus 2, which is less than or equal to x minus 8. Let's combine those like terms, those constants on the left, and we have 3x minus 4 is less than or equal to x minus 8. Remember, our goal is to get our variables together on one side and the constants together on the other side. So let's subtract this x on the right, and we'll do that on both sides. So we have 2x minus 4 is less than or equal to negative 8. And we're going to add the 4 to both sides because we have our variable isolated. We want to isolate the constant on its own side. And we have 2x is less than or equal to negative 4. If we divide by 2, we're going to have x is less than or equal to -2. Okay, let's look at the second one. We need to distribute this 4 through the parentheses on the left-hand side, which is 4x plus 4 plus 2, which is greater than -2x plus 4. Combine those like terms on the left, and we have 4x plus 6 is greater than -2x plus 4. We want to get our variables together, so let's add the 2x to both sides, and that'll give us 6x plus 6 is greater than 4. Let's move our constants all to the right, so subtract 6 from both sides, and we have 6x is greater than -2. We need to divide by 6 to isolate that x, and we have x is greater than -2/6 or -1/3. And notice that we have an or. Okay, we're not going to concentrate on that or just yet. What we want to do is we want to graph these on the same number line to start. So let's draw our number line, put our two important values on there, which are -2 and -1/3. Let's graph our blue inequality first. So x is less than or equal to -2. That's a bracket at -2, and it's shaded to the left, right? If you have your variable first, then your inequality, and then your constant, that inequality will point the direction you need to shade. Let's look at our red inequality. We have x is greater than -1/3. It's strictly greater than, so it's parentheses at -1/3, and it's shaded to the right. Now remember, from above, or we can go back and look above, in or, the solutions are values that satisfy either inequality, the union of the individual solution sets. So replace these inequalities with the color of the inequality, and your solution is blue or red. So where do you have blue or red? Well, on the left, you have blue from -infinity to -2 with a bracket, and the red is from -1/3 through +infinity. And we put our or symbol, which is the union. So this big U is another way to write or. So this is the union, or an or. -infinity to -2 or -1/3 through infinity. It's because we have blue or red. Now, next we're going to look at and notice above it says, and the solutions are values that satisfy both inequalities. This is the intersection. Look at this one. It's going to be really interesting. So we have our number line, right? And we're going to put our key numbers on here. So if you have blue and red together, that would be purple. So an and is whenever you have blue and red at the exact same time on that number line. So where on our number line do we have blue and red overlapping? So where would they mix and make purple? Nowhere. So our number line would stay empty. We won't shade anything. And the solution is the empty set. There is no solution. These two inequalities have nothing in common. There's no intersection. So remember that. Or is when you have blue or red, and an and inequality is when you have blue and red, or you get purple. You mix the two. Now, another way to write an and inequality is a three-part inequality. So they put the inequalities together. So notice in example 1, we have 2 inequality signs and we end up with these 3 terms. I like these because you solve it all at once and it spits out the interval. You just have to be careful because anything you do, you have to do to all 3 parts at the same time. It's no longer a left and a right side. So our goal is to isolate the variable in the middle. Our variable is b, and we need to first add 5 to start isolating that. And you have to do this in all 3 spots. So on the left, we get 5. We keep our less than or equal to. We have 2b in the middle, and we have a less than, and we have 9 plus 5, which is 14. Now, to isolate b, we're going to divide by 2. Again, do that to all 3 parts. On the left, you have 5 halves, less than or equal to, and you have the b, and you have the less than, and you have 14 halves, or 7. So if we draw our number line, we have 5 halves on the left, and we have 7 on the right, and b is in between 5 halves and 7, with a bracket at 5 halves because of the inequality here. B is greater than or equal to 5 halves, and parentheses at 7 because it's strictly less than. And look, it spits out that interval for us. It's 5 halves through 7. Let's look at one more example, a little bit trickier because, yeah, we have a fraction. But get rid of those fractions at the beginning. The LCD is -3. So multiply all 3 sections by -3. On the left, we'll get a +6. Don't forget to flip those inequality signs. You multiply or divide by a negative, you flip. The middle stays as just the numerator. We multiplied by -3 to get rid of the fraction, that denominator. Flip our inequality, and on the right we have -12. Now we want to slowly isolate this x. So let's subtract 1 from all 3 sections, and we have 5. We have -2x in the middle and -13 on the right. Now notice x is being multiplied by a -2. So we need to divide by -2 in all 3 parts. Again, multiplying or dividing by negative, let's flip those inequalities. Middle, we're left with x. On the left, we get -5 halves. And on the right, we have a negative divided by a negative. That becomes positive. And we have 13 halves. It already tells us that x is between -5 halves and 13 halves. See why I like these 3-part inequalities? I know that I'm shading between these 2 numbers. And they both have this equal sign, so I know I have brackets at both. So my interval is -5 halves with a bracket through 13 halves, also with a bracket. Thanks for watching. I hope you found this video helpful, and if you did, please check out some of my other math videos for some more help.